Hey everyone, thanks for coming to my talk. Can everyone hear me okay? Can you raise your hand if it's, okay, cool. Today we're gonna talk about bootstrapping the machine learning training process. So if you have been curious about how to do something custom with machine learning for iOS apps, we will review the end-to-end process of doing that. We'll go from defining the problem and gathering the data through to training a custom machine learning model that will be compatible with CoreML. We're going to focus on concepts that should be fairly timeless, though, because the frameworks and the APIs change so often. It's kind of a roller coaster ride, if anyone has noticed. And so I want to make sure that everybody will just understand the big picture so that you can learn any changes that come in the future fairly easily. So I also want to make sure that we stress how important training yourself and the learning process is, because that will give you the ultimate tool set for problem solving in machine learning. So yeah, I'm Megan, and I work as actually a general software developer at Novoda. It's an app consultancy, and it's based in London, but I work in a small Berlin office, and we're doing some cool stuff with machine learning for mobile. So just so that everybody knows what the outline of this talk is, first, we're going to go through the big picture because it's an ever-changing field, and so understanding the big picture is very important. And we're going to try to understand when it's practical to use machine learning for iOS, because it's a really big buzzword, and so it's important to know when it's a good tool and when it doesn't really make sense. And we'll go through what's available to us. And I tried my best to add a couple of things that were announced yesterday, but I definitely did not do a thorough job because it just came out yesterday. And we'll go through some end-to-end examples of, so at least one of them, depending on how much time we have, on defining a problem and training a custom classifier and having it ready to be used with CoreML. I'll do as much as I can, but it's kind of a big field. Okay, so WWDC 2018. I want to make some initial comments because it's probably on everybody's mind. So it's another year, and we have some more updates in the machine learning space. Okay, so I think this is actually kind of funny. So there were some cool stuff, but this actually is from yesterday. I could not make this up. And so I think we should actually make sure that this is a little bit more down to earth, because yeah, otherwise it's going to be really difficult to have an intuition for what's going on if you think things are magic, because Apple has a tendency to do that. So okay, so, sorry. We do have a new kid on the Apple block, but this is the underlying techniques that go along with what create-ML is. If anyone doesn't know what create-ML is yet, because it just was announced yesterday, it's a way to train custom classifiers or machine learning models within Xcode for very specific types of tasks. And previously, you would do this using a third-party machine learning training framework like Tensor Flow or Keras or a number of other ones, and you would convert it. And that was separate from the Apple ecosystem as we know it. And they had a converter tool that would bring us back to the ecosystem. But it is really cool that you're able to do this within Xcode Playgrounds. I played around with it a tiny bit, but I cannot comment on it so much more than that. So yeah, I'm just the messenger anyway. I'm really not a salesperson for any of these things, so I think I can criticize things and together. It is what it is. So yeah, okay, so for this stuff, keep a growth mindset because there's so much stuff to learn in machine learning. It can be really overwhelming. And if anyone doesn't know what this philosophy is, I really love it. So it's kind of simple. It's an idea that you can learn anything if you put enough time in an effective way. And this allows you to grow your skill set throughout your life. So I think this is important to keep in mind because people can be very overwhelmed by machine learning. Yeah, so this stuff is not magic, and it's kind of harmful to think of it like that. So if you think of it as magic, it's like giving a person a fish and feeding them for a day. Instead, we should try to teach people to fish so that they can eat for a lifetime. And so let's learn how to fish. So everybody might be at different stages of their machine learning journey. Maybe people have never done anything. Maybe people are already doing really custom stuff. Can I get a show of hands of anybody who's used CoreML before? Okay, cool. That's great, because just last year we didn't even have these capabilities. And has anyone used Tensor Flow before or any machine learning training framework? Okay, cool. That's awesome. So okay, yeah, no matter where you are in your journey, understanding the big picture is the more important part, because then you can zoom in on something specific. So if you have specific questions, I'll say this up front, or if you just want to like learn, I actually decided that it might be good for people to like book little sessions with me for free. So I made a little like easy homepage on this app, calendly.com, and you can book like a 30-minute session if you're interested. So it's going to be from like, a couple days later in the week. So, okay, let's make these possibilities that everyone talks about in Apple like advertised as like, thank you. I think they said in the Platform State of the Union, thank you for all of the awesome apps you put in the App Store with these capabilities, but they didn't give any examples. So here are some real examples. So this app called Summary. So I think it's cool to like look at products so then we can go through the technical details so you can like kind of see that this isn't just magic. So Summary is an app that's in the App Store, and its main purpose is to help people understand dense research papers. And I think this is really cool because I love reading research papers. I read like a lot of them every week, but I can't expect other people to do that. And also I think it's really useful to be able to just get the gist of something, sort of like the abstract. And so you can use this app, and it uses optical character recognition to like take a photo, to take the text in. You paste the research paper text into the app, and it summarizes it for you. And you can also like take a photo of it, and then you're able to decide for yourself whether or not you want to actually read this research paper, or if it's something that doesn't really align with your interests, and you can decide to do this for many of them. So it takes a lot of work and burden off of the user, especially because it's intimidating to read research papers. And I just want to show people like the thought behind this. So the guy who made this, he is featured in a blog post on Heartbeat blog, which is a machine learning for mobile blog, and he said, I read a lot of research in this field and decided that machine learning can be of great help if everyone can use it easily. That's why I started working in the field of machine learning on mobile devices. As I always read long articles and papers, I knew that the process of reading and understanding textual information took a lot of time, but this problem could be solved if there was an app that could summarize long paragraphs into short sentences without affecting the meaning. This is how I got the idea and developed Summary. And this guy, Sahil Chaudhary, he's only 17, and he's based in India. So maybe that gives you some perspective that he's obviously probably a really, really smart developer, but he's only 17, so how long could he really be doing machine learning for? It's something that should be accessible to everybody, and I think maybe this gives you the idea that you can also get started on something like this. So another app is called Nuru, and this is actually an Android app, but I don't really think it matters what platform it's on because the capabilities should be very similar for iOS. And Nuru, I'm going to try to play this video. I'm not sure if it's going to render. So it's a mobile app by a company called Plant Village, and it helps detect crop diseases in Africa. So you can take a photo, and it can diagnose whether a crop has a disease or not. And this is a huge improvement from having to do this manually, because it can be many people's jobs. Just look at a plant and decide whether or not it has a disease and whether or not it can be, I guess, edible or needs some sort of treatment in the fields in order to improve the growth of the crops. And so this can take a lot of the tedious work off of people so that they can focus on more interesting stuff. So shoot, I don't think this is rendering. So what I'll do is, it's a really cool video, and they use Tensor Flow to train this, and I'll tweet this out after the talk. Okay, so the big picture for machine learning for iOS. This graphic shows 5 different steps in the process. So before you start this, you have to define a problem. So that seems obvious, but I just want to make sure that people know that you have to define the problem explicitly to make sure you can even get here. So we'll use an example throughout the talk of training a classifier that takes images, or it can also take video if you extract the frames of someone making sign language gestures of the sign language alphabet. And so let's just say, for example, the task would be to have a photo of a sign language alphabet character, and you have to classify this. So you first need to collect data, and it's going to have to be data that's representative of what you think you're going to see in real life. Otherwise, it's pretty useless. And then you have to train the model. So You had TensorFlow and Turi Create, Turi Create is actually by Apple. And then you have IBM Watson and all Keras and all these other ones. And now you're actually going to be able to do this in Xcode. So yeah, so basically the gist of it though is no matter what the tool is, you have to have something to train the model in order for it to be able to classify something. And then after that, you have to convert it to ML model format, which is the core ML format that you need in order to use in your Xcode project. And with core ML 2, you can do this in Xcode for training a custom image classifier. So that's going to be cool because you don't have to use the conversion tool if you're going to do it that way. So previously, if you had TensorFlow or something like this, you had to use one of the tools available to convert it from that framework's format to core ML format. So core ML tools came out last year. It's really not honestly stable, but it is available, and it was a start, and it was able to convert from Cafe format and scikit-learn and Keras and a lot of other ones to core ML format. And then there's also TensorFlow, for whatever reason, was in a separate repository, not hosted by Apple. Who knows? And it was called TF Core ML, but it's open source, so you can see it. And then after that, you would import it into Xcode. So the ML model format would just auto-generate a Swift file. So that was pretty cool because at that point, you can just use the core ML APIs, calling like directly into your the Swift code that it generated for you. So yeah, so once you have the core ML APIs to use, then you're at that point doing predictions, and these predictions are going to be done on the device. You're not going to send them to a server. So in order to be able to attempt the machine learning, a lot of people think there are barriers to entry, and I want to put some of these to rest. So a lot of people think that you need a very large data set and access to high-end compute power, maybe a PhD in machine learning, and lots of time. And you definitely don't need all of these, and these kind of are glamorized by the media. So you do not need a large data set for a lot of tasks, and the reason why that is because of transfer learning, which has been around for years and years, and actually the only way to go right now for certain machine learning tasks. And Apple advertised it yesterday, but it's not made by Apple. This is a research technique. And then access to high-end compute power. You also don't necessarily need because of transfer learning as well, and also other factors, and we'll go into them in more detail. You definitely don't need a PhD in machine learning or any PhD at all. And then time is like something that you have to manage yourself, so you can decide how much you want to know about the whole machine learning and TENS process. You can chip away at it over time. So is it practical for your app? There are certain types of tasks that are more suitable for machine learning than others. And some of them, which are a little bit more tried and true for using machine learning, are tasks such as image classification. So a lot of people have probably seen this before with, the American Sign Language alphabet classifier or cat-dog classifier, which probably people have come across, or anything in that takes that form. And you can also do audio classification. So you can have audio, and then it will label what it is. And then speech recognition, text classification, gesture recognition, optical character recognition, translation, and voice synthesis. These are some examples, but it's not comprehensive. Maybe this gives you a bit of an idea for how this could help your app. So I think that, knowing these can help you embrace idea generation and experiment. And since you don't have to have all of these checked boxes in the barriers to entry slide, that also makes it easier for you to experiment. Okay, maybe this is actually a little bit outdated now, but this is a slide that I made, and I was in Rome at the time, and I was really liking this whole BCAD thing, and just kind of like silly. But since there was so much hype last year with Core ML, I decided to have our timeline look like before Core ML and after Dub 2017. So the reason why I think this is important to segment it like this is because we got Core ML in iOS 11, and if you have to support any apps before iOS 11, then you can't use Core ML, just like any other framework that comes out in a specific iOS version. And so what you have to do then is you're going to have to use something that was previously available. And before iOS 11, we already had machine learning capabilities, but you kind of had to roll it yourself. And you could use accelerate, which targets the CPU, or you could use metal performance shaders, which targets the GPU. And these are used under the hood, you can see on the right, for Core ML. It's just that Apple decides which to use for you, and that's abstracted away from us. And it's nice because we do have really simple, easy-to-use APIs. And what used to be, I did some experimenting with metal performance shaders in the past, and also for supporting backward compatibility. And it was a pretty, I don't know, Herculean task for me, who isn't a graphics programmer, even though it's fun. So Core ML makes it a lot easier for you. And then on top of Core ML, you have Vision, which it's a framework that in itself will have computer vision, or like one form of machine learning tasks. So it has things like object detection and face detection and barcode detection and rectangle detection. So basically classifying something that's in an image. And then you have natural language processing, which has been around for a while, but had some major updates last year and also some updates this year. And this allows you to extract meaning from text. So it allows you to detect the language and detect the part of speech and many other things that would allow you to do interesting tasks with text. And then you have Gameplay Kit, which wasn't highlighted at all this year, which was interesting. I still don't know much about this because you can only know so much, but it has to do with game strategies, and game strategies can have machine learning type representations, such as min-max classifiers, if anyone's heard of those. So yeah, for vision, we have object tracking, rectangle detection, face detection, person extraction. This is new. I have not tried this, but basically it can take someone out of a scene, and it can extract them from the background. So it's sort of like when you Photoshop yourself maybe onto the WWDC stage or something like that. So then you have to have barcode detection, text detection, horizon detection, and image alignment. So lots of capabilities there, and they're right there for you to use directly. You don't have to do anything custom. So this is from last year. So basically you have the Core ML model, and then once you're able to, okay, so yeah, maybe it's a lot of information at once, but basically from our app developer's perspective, once you have a Core ML model, you're able to use it in Xcode. And now with the new APIs, you're actually able to do some training as well in Xcode, and that's with Create ML. So is it just hype? Maybe. Machine learning is a powerful tool, but it's still just another tool. So how can we think about machine learning as mobile developers, iOS developers specifically? If it can be solved, what you're trying to solve without machine learning, I would recommend you just do that, because yeah, you wouldn't use a random tool to solve any random problem. Like, this goes against critical thinking, being a software developer. So same thing applies for machine learning. So machine learning is definitely a different way and kind of paradigm shift in how you are approaching problem solving. So if you think of a basic unit of problem solving as a function or a model in machine learning speak, we can think of the machine learning approach as enabling a machine to learn the function on its own. So such as classifying sign language alphabet images. So instead of hand determining and defining exactly what you're looking for in the images up front in like a deterministic way, you're going to be training a model to, over time, extract the features itself and come up with a function that's able to classify this. So a very other extreme example would be you would not use machine learning to determine if a number is even or odd, because this is a one-line function. Then you would spend way too much time using machine learning on it. It actually would not be deterministically correct using machine learning, because machine learning is a probabilistic model. So if you decide to use machine learning, still go with the simplest solution. You then have to decide if you want to do it on a mobile device. So machine learning on mobile, as we know it right now, is that you can make the predictions on the device. So you already have the model trained. You're not doing further training on the device using native capabilities. And so the reasons why you would want to do predictions on the device are for two main reasons, and that would be low latency user experience. So if you're using video, then you if you didn't do it on the mobile device, then you would be sending frames to the server, and you would have to wait for the predictions. And this would be prone to a lot of bad user experience situations if you have bad network connection, something like that. Maybe the server isn't super reliable and goes down or something. So instead, you can just do it right on the device, and then you have a obvious speed up. And another important reason why you would do predictions on the device is for user privacy, because you're not sending the user's data to a server. And so at the very least, it's kept on the device, and there's one kind of point of failure. And if we can assume we trust Apple, then we can trust that they're making predictions with the mobile model with the user's privacy in mind. Okay, so what's available from Apple? So as of last year, we had, and I actually haven't dug through everything yet for this year's announcements, but they've had a couple of pre-trained models for us to drag into Xcode and use for predictions right on their website. So they have image classification of 1,000 common categories, and these will recognize trees, animals, food, vehicles, people, so just generic objects with no specificity as far as like granularity or brand or something. And the reason why so many of these exist and why Apple can use them is because there's a competition called the Imagenet Competition. And Imagenet is a data set of tons and tons of images that are labeled with these 1,000 common categories. And over time, there's been a competition winner, which happens to have like a really, really good classifier. And usually it gets faster to make predictions over the years. And so those have been luckily made available to the public. And so Apple can just use those and convert them into Core ML format. They did not make these up on their own. So we have SqueezeNet and MobileNet, which are, these are the models, and they are suitable for using in a mobile device because they're smaller. And then you have a scene classifier, which can detect the general scene. So not just like the specific object, but if you're in a forest or on the coast or at an airport terminal, it will be able to classify that. So these are already in ML model format. You just drag them into Xcode. If you need something more custom, and likely you would train a custom machine learning model. And now we're going to be able to do this in Xcode, and that's awesome. But previously, and you can still do it the other way, is you can use a framework for training, such as Tensor Flow, Keras, Turi, Create, all of these, and then you convert it to ML model format. I mentioned this before. Okay. So it's been quite the year, and so lots and lots of tools. I guess the gist of it is they are changing a lot. I even made my own. It wasn't open source, but this was using transfer learning in order to train an image classifier, trying to use the Python Objective-C bindings, calling in from Swift playgrounds. It is held back by the language, though. Luckily, Swift for TensorFlow is fixing that. So beyond the cat-dog classifier, we will train a model to recognize American Sign Language alphabet characters. So what is the training process, and how do you bootstrap it? You define the problem, collect the data, train the model, convert, import to Xcode, and predict using Core ML. So the mobile-specific concerns are the size of the model, the time it takes to run predictions, and supported layers. So for American Sign Language classifier, you collect the data, and so there are lots of open data sets. So this one, there's a UK university which has compiled a pretty good data set, and defining what a pretty good data set is actually not a science. So what you need to keep in mind, and I think this is actually really, really important, and one of the things that's holding back machine learning as a field, and this is because you need to try to define what your users will look like, and what will be most useful for the model when it's in the wild, making predictions with your real users. And so once you define that, which is tough, then you're going to have to try to collect data that would train the model to be able to make predictions and would actually be useful. So then you train the model. Okay, so deep learning. We're going to train this using like the type of machine learning classifier we're going to use is a neural network, a deep neural network. So just to review, a neural network, is just one like model type, and It has basically input and then layers, which will do transformations on the input, so an image represented as a matrix. And then at the end, it's going to have an output, which is a probability distribution of what it thinks it is. It's actually pretty simple if you think about it like that. And then deep just means it has many layers. So the original definition of a neural network just had one layer in the middle to do the transformation. There's this glossary on the Heartbeat blog too, which I really love, and it goes through a lot of these terms. I'll post the slides after. So it's probably really useful to look at what this deep neural network can look like, and this was a really good representation that's been pretty popular online. I have the reference in it. So, really sorry. Okay, so you have the image as the input on the left, and the image is going to be represented as its pixel values in matrix form. And then if you have an image of a car and you're trying to classify the cars, then these layers that are in the middle are going to do transformations on this input. Try to abstract those details away for right now on like what the transformations are, because that's too much information for this talk. But at the end, you're going to have a probability distribution of what it thinks that image is. So instead of looking at it like a black box, we can actually use, we have some tools to see what the neural network is seeing at a particular layer in the network. And so that's what we have on the top. And at the beginning layers, you're going to see, or the neural network is going to be able to recognize very basic features, such as edges. And then towards the middle, it's going to represent more complex features, such as, so edges, corners, or maybe wheels. You can see a car door. So higher level abstractions. And then towards the end, it's going to be able to hopefully recognize a car and be able to differentiate an Audi versus BMW and the model as well. So maybe you get an idea that in the early layers of the neural network, it's extracting features which are very generic and don't just apply to cars. This could also apply to detecting people or buildings or other images. It's just trying to detect sort of and understand images at all. So this actually really, really helps us, because back in the day, people used to train deep neural networks from scratch. And now it's actually recommended to, instead of doing that, just reuse the work of really good academic work and work of giants in industry in order to just use those earlier layers as is and just train the last parts of the network in order to classify something more specific, such as classifying the cars or American Sign Language characters or a flower classifier. And you do this by utilizing transfer learning. So that's what transfer learning is. You are using knowledge learned from the source task, such as MobileNet, which can recognize 1,000 different categories, to train a target task, such as the American Sign Language classifier. Don't reinvent the wheel. This, I don't want to run over time, but there is mathematical reasoning behind why this works, and that is, in a nutshell, because neural networks are universal approximators for theoretically any function if you give it enough data and the initial conditions allow for coming up with a function after enough training. And so transfer learning should work because, of course, if you can approximate any function, you should be able to build off the work of a previous function to customize to your own. And so since you can use transfer learning, you don't need that much data. And it depends on the problem, and I encourage you for your specific problem to really research it, because likely someone has tried something like that or something similar enough, or you can ask the community. And you can, as a general rule, you can just use hundreds of images per category when you're using transfer learning, because you just need to train the last couple of layers. So where do you get the data? Kaggle is a really good resource. It has over 6,000 data sets, and it ranges from images to data on crime statistics by governments and bike share data and Yeah, you name it, and people are uploading more and more every day. There's a competition that runs, or many competitions that run on Kaggle, and people compete for the best classifier. And so when this happens, there's usually a new data set. CERN just released a data set. And so, yeah, like really big institutions that are doing really impressive work release their data. So that's awesome. You can also Google for them. Or if it's images, you can record video yourself and then extract the frames using a tool that will do that, such as FFmpeg. If you don't have enough data, then you can do data augmentation. So there, I left a video. It's just 10 minutes of roughly how you would do this. And you're just going to be doing like cropping and rotating and shearing in order to bulk up your data set. So assuming we're using Tensor Flow, and I really don't think you should focus on the frameworks, to be honest, because they're changing so much. But say we're using Tensor Flow, we're going to go through Tensor Flow for Poets, which is a great tool, or a great resource for training a custom image classifier. And so the first step is you put your data set into subfolders with the categories. And it's important to remember that this is labeled data, meaning that it already knows the category up front when you are starting the training process. So this is supervised learning, if anyone's heard of that. So for this American Sign Language data set, we have each of the characters, and then we have, I actually have 3,000 images. And I used that data set I found from the UK university, but I actually bulked it up so that it had covered more demographics and skin colors and people. That's important to remember. So let's start training. We can't use Swift for TensorFlow quite yet. It's in early stages, and you can join the mailing list, but it's not quite ready yet. So we'll do this in Python, and basically, for this tutorial, you can try it afterward. It has the instructions for training a flower classifier, just like the Apple one, and this has been around for years. And you clone the repo, and then basically use a virtual environment, because that makes it easier on yourself. And then all you do is you copy and paste your data set into their repository, and then you kick off TensorBoard, which is this awesome tool, which I think is really good, because I don't think Apple has anything like this yet, unless we haven't heard about it yet. TensorBoard is a monitoring tool to show you how your training is going, and TensorFlow is a lot more stable than anything else I've seen out there. And then I set some environment variables, so this is specific to this framework, but it is important to remember that you need to give the training process enough information about like what your data is, so like the size of your data, so that if you can imagine, if you gave it the wrong size, then it's going to maybe just center crop it, or like, and then it's not going to learn the model. It's not going to come up with a model that represents the data you actually wanted to give it. And then you give it a base architecture, so we'll use MobileNet. And then this is from the tutorial. You just use this script that they have, and it's open source. You can see what the script is doing, which is really nice. It's not like black magic. And then the important things to set are the training steps. So this is like how many times you're trying to you're trying to pass data through and train the model. So generally more would be better, but there's diminishing returns, and you can see this in TensorBoard, like how it's doing. So 500 is a good starting point, and they tell you this in the tutorial. And there's like reasoning behind this too. And then you say like which base architecture you're going to use on the second to last parameter, and then you just give it your image directory. So I pass the data set in, and then it's gonna run, and you're going to get output for how accurate it is. So this is something that actually you need to investigate a little bit further, depending on the problem, because the accuracy is based off of the test data that TensorFlow has split your data set into. So you have the training data set, which we'll train the model with, and we'll have a validation data set too, and then you have a test data set, which won't be used in training and will be try to represent your real world data, which is only as good as the data that you actually gave it in the first place. But yeah, you need to, in addition to this, test this in the real world. But in theory, this is a 95.3% accurate classifier, and it took 20 minutes to run on my MacBook. So it uses the CPU because we don't have, we don't have NVIDIA GPUs on the MacBook, so it's like difficult to access that. Okay, so this is the output that TensorFlow would give us. So it's 95.3% accurate. That's the important thing. And my MacBook, it's going to depend on the quality of your hardware, but I have a MacBook that a lot of people probably have something similar, and it has an i7, and it has 16 gigs of RAM, and it has 3.3 gigahertz processor. So, and it's from 2016. And then after that, you have a trained model, and we need to convert this from TensorFlow to ML model format. So that's where this tool comes in, TF Core ML, which is open source and not hosted by Apple, but it's available. And I made just a folder called convert because I thought it was easy, and I put all the files that you need, and they go through in the GitHub page in order to convert it. And then this is all you need to put in the conversion script. It's also in Python, but it's really not much, so you don't need to know Python. And you're basically just importing TF Core ML, and then you're saying where your model path is. So this is the graph that TensorFlow came up with. And then you're going to also say where you want to save your ML model format. And then you also need to give it the output feature names. And this is very important because if you don't give it the output feature names, this will be like telling the model what the output probability distribution actually corresponds to. If you don't give it this, then it won't know how to like assign labels. So it will just have like kind of not specific way of predicting. It won't know that it's letters because this is just a machine, right? We need to give it information. So it just works. I don't know. There are some issues you can run into this, and I think the best thing to do when you're converting this and you run into issues is just look at Stack Overflow, and then you can also file issues in the repository, and you can also ask me on Twitter, and you can tweet. There's a couple people who are really, really helpful with this. And then you import this into the Xcode project, and you just drag this in. And you can see that this is as of last year. I can't really comment on anything from this year for this part yet. Once you drag this into Xcode, it automatically generates a Swift file. So you see we have our ASL classifier, and it generates ASL classifier input class. And this really works well. I haven't had actually basically any issues with this. And then you predict using Core ML and Vision if you want to, if it's an image classification task. So the reason why Vision helps is because if you're using Core ML directly, you have to use CV pixel buffers. If you use it with Vision, then you can just use CG images. So that's a little bit easier. So I can't actually comment if this is exactly correct for the new APIs, but in a nutshell, you should be able to use the new APIs because I'm sure they're very, very simple. So the first thing is like you create the model, and you just instantiate the Swift class, and then you wrap it in a Vision model if you want to use the Vision advantages. And then you create a Vision Core ML request with the model and the completion handler for what you want to do with the results when you get them back. And then you create a request handler, and after that, you're going to just perform the request on the handler, and make sure you just don't do this on the main thread. Okay, so that's actually it as far as the big picture. So you collect the data, train the model, convert to ML model format, import to Xcode, and then you predict. How much time do we have left? 5 minutes. Okay, cool. So we can go through another example. So I think it's cool to go beyond image classification using very, very similar techniques, like literally the exact same tutorial. So we can do audio classification, and this will work pretty well if you have small, like very short audio clips. For longer audio, you're probably going to have to use something that also involves like a time dimension. That's a bit different than like using a regular convolutional neural network, which is what TensorFlow for Poets is using. Okay, so not too many details, but basically same steps. Define problem, gather data, train the ML model. To find the problem of, we can use this urban sounds data set, which is really nice, and it's by NYU, and we can try to classify audio that you might hear on the street. So there are a couple different categories, such as an air conditioner, car horn, children playing, drilling, etc. And so you gather that data. This was pretty good. I went through, kind of took a random sampling of them. should we use the raw audio, though, that they provide us, which is in a WAV format? And I did some research on this, and there's luckily a lot of good research papers and some blog posts on this exact data set. And no, the answer is, from experience that people said, it's too computationally expensive. So a trick you can do is you convert the wave to a spectrogram. And then we can represent audio as an image. And so the first dimension for representing the audio as an image on the x-axis would be time. And the second dimension would be frequency. And the third dimension, which is to give the training process more information, could be loudness, sound intensity, and you can represent this as color. So I literally just copied and pasted the data after I checked it into a folder that was labeled with folders of the categories. And then I had, I made a script. I can post this stuff too. I just kind of want to clean it up with the new CoreML stuff, if relevant. So you can convert this to spectrograms, and I just had a small Python script that did this. And so this is a spectrogram of a car horn, this is of a siren, and this is of an air conditioner. And you can see that they're very distinct, so a machine should be able to distinguish these. And then I just ran the retrain script with the same default parameters just to see how it did, and with the new image directory. Train the model, and this took an hour to run on my MacBook, and 77.1% accuracy. Pretty good. So quickly, TensorBoard is a really cool tool, and there's a lot of good videos and resources on this on the TensorFlow website, especially the TensorFlow Summit from this year. But the most important thing, if you want like a 5-second overview, would be the top one accuracy, which is what's the probability that this model is classifying what it actually is and puts that category as the top category. It doesn't necessarily have to be 100% accuracy that it thinks it's a car horn, but it has to be the top one. And so you can see over time, these are the training steps on the x-axis, it's getting more accurate. But then after a certain number of training steps, it has diminishing returns. So you can actually overfit your model to your data. So that's something that you have to learn more about. I can't cover it here. Okay, so this is a lot of information. I'm really sorry if people are really overwhelmed. But remember that as mobile developers or any type of software developer, there are similarly lots of different areas of the stack. And there are these layers of abstraction that maybe people have seen before. This is a nice representation from this lady's blog. She wrote a really nice post named Devin Sagel. She's based in San Francisco, and I have links to this at the end. And what she's trying to say in this blog post, which is great, that you shouldn't get too overwhelmed by all the layers of abstraction. It's actually important to remember and like only focus on the things that you need at that time, and you have to take other things as given, because if you're not strategic with this, then you just get overwhelmed and you can't really move forward. So keep that in mind. And where to find inspiration? You can look at open data sets, read research papers. You can use the summary app in order to help you with the research papers. And follow, like, there's so many resources, so I think it's nice. I want to like pass on what has been helpful to me in this process. And the Harpy blog is fairly new, but it's really good. OpenAI is a company that does really cutting-edge research in machine learning, and they'll post about their research as well as areas that they think are worthy of exploring. And so maybe the ones that are worthy of exploring and are the most cutting-edge research are things to stay away from, as far as maybe they're too hard of problems right now, and wait until there are advancements, because the field moves very fast. You can reproduce results of research papers, and this is awesome because some researchers are now, even if they're like academics and they're studying machine learning physics or something like this, they might not be programmers day to day, but they're using GitHub a lot, and they'll put a GitHub repository and sometimes a Docker container to research or to reproduce the results in an environment that's easy to replicate. So that's really cool. Just check the licensing and attribute proper credit if you do this. Looking forward to the future. Yep, so I want to try to somehow cover CoreML 2 stuff in some format going forward, blog posts or something like this. I have some more conference talks in the next couple of months, and then we have machine learning interpretability, which is getting better and is a hot topic right now. So it's what is happening at each layer of the network and why, so that we can demystify what's happening in these models and so that we can trust them more. We also have Swift for TensorFlow, which Chris Latner and Richard Way and a lot of smart people are working on, and this is moving quickly soon. Review. So just so everyone remembers and isn't totally like frazzled because there's a lot of information, we went through the big picture and make sure to keep that in mind. When it's practical to use machine learning for iOS, what's available to us, and end-to-end examples. So I have like a lot of attributions because I seriously spent the whole winter and a lot of time in the past couple of years just like in the library, and I just wanted to pass them to you. And yeah, so thank you for coming and keep in touch. I try to respond to everything I can. This is my Twitter handle, and if you want to book one of these slots with me, I thought it could be useful for some people, then feel free to do it, and it'll be in the slides and I'll tweet it out. Thank you.